Let's jump into the agenda. Uh, First, I want to talk about the list of possible ways to do the job to just share data between RT systems and host, and what are shared variables, its types, and its usages. And with a small demo, we'll see how to create and use it. And extension of the demo, we will see how to really pass data here and there with a small use case. And at last, we'll conclude it by discussing its advantages and disadvantages. I'm just jumping. And in the list of methods to communicate between RT systems and host here we can consider PC2 um, as the topic. We will be we can use shared variables. Specifically, it will be network published shared variable that we will see in a bit. And apart from that, we have three more possible ways to do the job: network streams, TCP/IP, and UDP. Among these first three, it is more or less, it's just using TCP/IP protocol only. So and the first two is just a wrapper around it, nothing much. And shared variable, these are all the variables which will allow us to share data within application or across applications, also across devices, which is basically through network. And a small history behind it, the shared variables are available from LabVIEW 8.0. So as a trick, we can also communicate data between different LabVIEW versions by using shared variables, different bitness too. So as a predominant type of shared variable, we'll talk about single process and network published. Going into single process shared variable, this is more of or very similar to your global variable, where you can share data between different loops or different VI, but it should be in the same application instance, right? But here in single process shared variable, either it should be in the PC code or it should be in the RT code. And you can also achieve deterministic data transfer between loops by enabling this RT4 option that I will show you in a bit. Then what more advantage we will get by going into shared variable, right? So only advantage of going into shared variable instead of global, especially the single process, it's easily convertible into network published shared variable in later time. So how it looks in the project under your library, it will just look like a small global, as I was saying. If you enable RTF4, you will be seeing a small purple vertical lines here. You just need to drag and drop in your block diagram. Once you do that, this is how it looks. So this is a numeric type of small single process shared variable. We'll move into network published. So this network published, this is our hero of the session also. So this will be really useful to share data between applications or devices over network with the help of shared variable engine and NAPSP, which is NI publish and subscribe protocol. Shared variable engine just host the variables, and rest of the things have been handled by NAPSP only. So how that looks in the project, simple difference, instead of globals, here you see two globals and a small wire have been connected to it. If you enable RTF4, the same purple vertical bars will come in here. Uh, yeah, how to create it and use it in LabVIEW. We'll see a small demo by going into LabVIEW. Uh, Before create any variables, shared variable, you might have to have a library creator. For that, you just need to right click on your RT target. Here I'm using Myrio and go and create a library. So here you can see in the folder I'm keeping this library. Let's create our first shared variable. I click on my library, go to new and variable. Here you can name your variable. Let's go with single process shared variable. And here the type can be defined. Here you have list of variables can be selected. Single process, network published, and IO alias. This we did not even hear, right? So this one is simply if you want to bind any of your IO from your chassis, if you any model connected AI, AO, or DIDO, any of the pin you want to bind with any shared variable, you can go with this option. When you do that, you might have to bind into your IO variable here. Anyway, let's stick into the topic. Let's see how to create a small single process shared variable. I'm just going with timestamp enabled also. Let's just go with double itself. But if you want, we can see, we can use any of the data type which is available in LabVIEW. You can also use any custom control if you want to use it. Let's just go with double only. And in the description, you can have any description here, which will be really useful when you use context cell for it. And as you can see, this network and scaling are disabled since it's not a network based, not a network published one. So these are all disabled. But still, you have an option to choose this RT54. If you want, you just need to enable this checkbox, and then you will be getting the FIFO type can be chosen. So you can go with either single element or multi-element. If you go with multi-element, you can decide how many, what is your size of your FIFO. So you can choose it. So just to keep it simple, I'm going with single element and RT54 enabled so that we can see that vertical bars. I'm just dragging and dropping into the block diagram. This is how it looks. Control H. You can see this is how its address also will come. Double slash dot slash the variable, the library name, then the variable name. If you want to change this into, currently this is coming as a read mode. If you want to use this as a write mode, I'm just taking a copy of it and go to access mode, click on write. Here you can use it as with write mode. This is how you can create a single process shared variable. For network process, let's go into the same library, new variable. You can name yours. Let's say network published shared variable. It's a short form and go with network published. Here already network publication have been selected and timestamping have been selected. You can't uncheck this. This is by default. And let's go with double only. Description, let me give network published shared variable. Network. Here we have that option enabled. So you can go and have your buffer here. So if you want, you can go with n number. So this will be your basically size of your buffer. And on top of it, if you want to enable RT54, you can enable it. And here, if you want, you can go with multi-element. But one catchy thing is here, when you go for multi-element in this FIFO, you need to make sure what number you are using here, and it should be matched with here too. So that this will work fine. This is a recommended number. For now, again, for time being, I'm not going to go into this. Let's go with the default options. And this is a double right. We can also do the scaling here if you want. Let's not go. And this is your first network public shared variable. And here you can see this double global coming with the wire. Just drag and drop into the block diagram. And in context help, you can clearly see now address have been changed to the target name, which is Myrio here. So Myrio, the library name and the variable name. And yeah, we were enabling the timestamping, right? So to enable that, we just need to right click on this timestamp, show. Here in network published shared variable, timestamp, show. So that you can see the timestamp also. Whenever it writes with a new value, you can, then when you get it, you will see that with the same timestamp with whatever you have written in the past. So, yep, this is how you can create and use it in LabVIEW. Any questions? And now I'm going a little fast. Okay. Let's see a small demo on how to use it. Here I have attached a small video by going with for timestamp for read mode. Yeah, read mode only we have enabled, right? While you're writing, you will be passing that timestamp inside to that node. When you're reading, you will be just getting the timestamp, whatever you, whenever you write it, that timestamp will be read in your code. Yeah. So going forward, I'm just using a MyRio to show this demo. And I don't want you to worry about what module, how it is connected and all. A simple thing, a physical LED is connected with a DO pin. This orange is coming from the DO pin, DO 0, and this black is coming from digital ground, nothing much. In the project, if you see, Myro is connected and some shared variable have been created. In the first level, I'm just checking whether my Myro is connected or not, just to make sure. If it is not connected, I need to confirm that is connectable. So I'm just checking here. So here you can see that is disabled. So I'm just going forward and just wanted to show you that what kind of shared variable I have created here. I have just given LED on as a name and going with network published, obviously. and I'm going with data type as boolean. And rest of the pages I'm just going with the default option apart from description. In description, I just give some a brief description about like what the shared variable is going to do. It's just going to turn a LED on or off. Apart from that, all the pages in this tab, which is just going with the default options. Yeah, and same goes with the next shared variable, which is also a network published one. The name is different, stop PC main. I'll tell you why I have given this name, and same small description about it and all the default settings. Yeah. Now moving into the PC code, here you can see a LED which is giving information to my LED on shared variable, which is parallelly being read in my RT code, sending into my digital output connection. So I'm just using C port of my IO here and DIO 0. I just configure that as a DO in my RT code, um, just showing how many things are available here. And apart from that, in the opposite side, I just want to show something from RT to PC. That's why I'm using a stop button here. So this stop button sending information to the stop PC main, which is always read in the PC code to stop the PC code. So if I click stop here, it should stop my PC main also. And at last in my RT, I'm just using a reset Mario low level API just to clear off everything after I'm done with all my job. Oh, at first, I'm just running from my RT main code, where it will also take care of deploying my shared variables to the shared variable engine. Then I will be running my PC main. Now, when I click on this LED on button, you will be seeing this physical LEDs also turned on. So off, here also it turned off. And now I'm going to click on this stop button by turning it on. When I click stop, could have seen both LED have turned on. Also my PC main code have been stopped. The physical LED have been turned off because of my reset Mario code. And afterwards, I just want to make sure my shared variables got undeployed. Here you can see deploy and deploy all button. So if you're doing some debugging, you want to manually deploy it, you can use this option deploy when you want to only deploy a single library or something. If you have more libraries, you have to go with deploy all button. So that is something I wanted to add. So that's all about the demo. Yep. There is a latency because I'm using a while loop. I'm not using a time loop, right? There will be non-deterministic behavior here and there. I just wanted to keep it very simple. Those who are getting started with my RT targets, just to keep it simple. That's why I'm just using a single while loop. For sure, you will be seeing some undeterministic behavior there. Let's move into the next slide, where once you master this nodes, right, shared variable nodes, my suggestion will be you can also explore this option going with low level APIs of shared variable. In your function palette, you can see data communication. Underneath, you have shared variable library, where you have list of APIs to be used for shared variables. One example I just created and shared here with the same example what we have seen in the demo, right? Uh, just I can't show the Mario for different reasons. That's why I just added a small LED here. Apart from that, code is really same. I'm just going with what is the question? Just curious to know, can we pass object instance via shared variable? Hey, it's a good question. I don't know. Even I have to try. I'll try and let you know. And continuing with the low-level APIs, only catchy thing I was stressing about the address, right, in the past demo with LabVIEW. So there we have seen, right. So this you can get this reference from this function also when you create a constant. There you can see one more addition, this ni variable PSP. So this is where PSP kicks in, and rest all of our address, myrio network published SVs, which my library name, and LED on, it's my variable name. So I just need to use this and open connection, read the variable here and pass it to my devo. And at last, if I'm done with all the things, reset and close the connection. I'm doing all those things in RT code because uh, in reality, we will be creating the code in RT, and eventually we'll be creating a exe out of it and put it as run it as a startup in our RT target. So if you do that, you really need not to worry about RT code there. So only for understanding purpose, I'm just showing the code here. So in that case, you just need to really worry about when you run this PC. Once that is already in memory, which is in the shared variable engine. So when you run your PC code, that address will work fine. So here in the PC code, I'm just simply sending the LED status to it, nothing much. So once I do that, automatically here it will be red and update my indicator as well as my DO. So that's all. And yeah, I think this time for conclusion. As an advantage, we have seen that it's really easy to create and use it in Labio if you're directly using nodes. You need not to worry about the IP address or extra things ports. Those settings you need not to really worry about if you're coming and using shared variable. Shared variable engine and the PSP will handle the rest. And if you want any deterministic approach, you can always enable this RT54, that will do the job. And that this will always work with your RT target only. So, and with a time loop, obviously. So, as an extra advantage, this is a recommended protocol for process data communication where your latest value is paramount. So, you are really worrying about your development time and the latest value, you can obviously go with shared variable. It's really easy to use and it support all the configuration, single write and single read, multiple write and multiple read, multiple read and multiple write and single read. Also, it has a compatibility with Measurement Studio and CVI. Yeah, but you can also see this thing. That's where disadvantages kicks in. So in terms of performance, it's not best, but it's better. But coming into disadvantages, latency can easily arise because of your shared variable engine processing. How come? If you go with timestamp enabling, RTFIFO enabling, buffering, RTFIFO multiple element, if you do all those things, obviously latency can come. Uh, in those cases, and same time you want to do high speed data streaming better, you should go with network streams. I hope that we can talk in the next year or in between any whatever event comes in, I will talk about network streams. And one more challenge with shared variable, if you have anything to debug when shared variable engine got failed, it's a little tough. The error will be little generic, so you need to really I mean, get used to it. One tip and trick I can give: if you feel that something wrong with your shared variable engine, go to Task Manager and type ni tagger service, and you can always go with start, stop, and restarting it. Most of the time, it will resolve your problem. Yeah, I think I'm pretty much done with it. So the references I have taken from NI's documentation using the lab shared variables. If you directly type this characters in Google, you can always get it. I don't know whether this PPT will be given to you or not. So if you see in recording in future also, just type this actual word in Google, you can get this document as a first link. And here you will know more about shared variables and its types and a lot of benchmarking from NI. And if you're really worrying about what protocol, networking protocol I want to use, you can explore this topic where it will be elaborately discussed with network stream, shared variable, TCP, UDP, and web services. And Labio examples, obviously. I'm using 64-bit, so that's why under C program files in Labio examples folder, data communication, shared variable, there is a project that will tell you everything. Just to know basics, but there is no RT target connected there, but you can get a grip of it easily. If you use 32-bit, simply go C program files 86. It should be the same one. Yep. Any questions? How do you consider TCP as an alternative? I'm not sure. uh, but TCP, in my thought, I need to know more about it, right? How to open the connection and how to use it for different data type. How can I just build it, format it, and send it to it. And when I get it, I need to obviously parse it. I feel like it's more job to do there. If you're getting started with RT, I feel like this is a shared variable is the go-to option to learn more. I mean, once you get a grip of it, you can always learn more going into very low-level stuffs like TCP and UDP. Anything more? Thanks, Christine. Okay, shall we move ahead? Okay, can we read the shared variable using Python or any other programming language like LabVIEW sharing? Python is reading for further processing. It should be possible because it's just written on top of TCP, right? So if you know the particulars, like if it's streaming from what port, if you know those particulars, I think it should be possible. Yeah. Again, Atul, I'm just repeating. I may have to explore and check on this. This is a good thing. Even I'm getting new ideas from you now. We can check this out. I think Christian, you are pro then. You know a lot. Okay, I'll proceed forward. It's time to thank you. Thanks, GLA Summit. I think this is my first time I'm presenting in GLA Summit. And yeah, to get in touch with me for further queries and info, obviously for Atul, I'll do that. Please connect with me and LinkedIn in the name of Shivamanikandan. And this is my work email address, shiva@arosystems. If you guys wonder what are we doing in our company, please do check our website and get back to us. Thank you.